Turning waste products into something useful is always a good idea. If it saves energy and makes for a cleaner environment, it's even better. And if it's a learning experience, well, we'll show you next on Show Me Ag. Welcome to Show Me Ag. I'm your host, Kyle Vickers. Thanks for joining us. The University of Missouri is known for practical research that solves everyday problems on farms and ranches in our state. Folks there have discovered some products that might normally be a disposal problem can be turned into an asset. And students are gaining first-hand experience in biology, marketing, and business organization, creating what may be a saleable product from what many people would call waste. Our guest tonight is Tim Reinbott, the Superintendent at the University of Missouri Bradford Research Farm and Extension Center. Thanks for joining us, Tim. I appreciate it. Tell us a little bit about how this came about.
Well, thanks, Kyle, for having me. Well, we've been working with campus dining for several years now. We have had some vegetable research projects going on, and what better thing to do with those excess vegetables than take them to campus dining. As a matter of fact, one day, I've got two daughters at MU, and one of them called me and said, "Hey, Dad, did you just bring some specialty melons out to campus dining?" I went, "Yeah, well, I'm eating one right now, and it's fantastic." So we had this great relationship with campus dining, and they're also very innovative and looking for ways to conserve food and waste, and they actually measured how much food the students were throwing away. And they found out for each meal, they were throwing away 4.5 ounces of food. And if you combine that over a whole year, that's 270 tons that was going right to the landfill. And we've always at the MU Bradford Farm thought we need to do some innovative low carbon footprint enterprises. And we got to thinking, could we take that food waste and do something with it? Well, we also have some partners at the horse farm that are always asking, what can we do with this excess bedding that we have? We've got to pay people to get rid of it. And we thought, hey, food waste, horse bedding, perfect combinations to make compost. And it started this whole ball rolling then.
That's really a whole cycle from the products that you're growing at the farm that's being used in the food. This is a little different because I don't remember any fresh vegetables or fruit when I was in school. So that's the first step. But then there's a lot of food waste and thousands of students.
Sure. Over 10,000 meals per day that MU serves. And not just MU. Look at all of our universities, all of our hospitals, our other institutions or businesses that have food cafeterias.
Well, before we continue our conversation, we visited the Bradford Research Farm to see their composting program in action. You'll see it takes a lot of dedicated individuals across multiple disciplines to keep this program running smoothly.
The MU Bradford Research Center is a plant sciences and natural resources research center where really the rubber meets the road. From projects coming from the laboratories and the greenhouses, basic type research to very applied research. Everything that either is helping the farmer directly, like a variety trials or screening herbicides, to that backbone to the new discoveries such as in drought tolerance and developing new varieties that are resistant to diseases. But then something like this compost facility, we were working with one of the vegetable researchers. They were growing vegetables, had all these extra produce, and we started taking it to campus dining. But this is a great opportunity for students for locally produced foods and what have you. And before too long, we developed a nice relationship with campus dining, and they were concerned about the environment, and they had done some surveys and some weighing and found out that students threw away 4.5 ounces of food per meal every day. And it's wound up to be 250 tons per acre. Tremendous amount of food just going out the dump. And that would have to go to the landfill. So we got to put our heads together. So, you know, what would be kind of interesting, maybe we could take this food waste and make it a compost. Well, we also knew from our neighbor South Farm, where they have the horse facility, that they were having trouble getting rid of their bedding material. They clean their stables out, they'd have all this straw and sawdust and manure. But hey, this is the perfect combination of food waste and horse bedding would make good compost. So that started this whole idea to start creating this closed loop zero carbon system.
Behind us is our actual building that we use for the composting, and basically we bring in food scraps from the dining halls and mix them up with the mixer over there, and once it's mixed, once it's broken down and the mixer is actually full, we start putting them into the bays just like this, and it takes anywhere from a month to 3 months to break it down using aerated pipes, and eventually we'll get a product that can either be sold or it can be put on like vegetable plots here that can send the vegetables back to Mizzou. In the mix is any types of food scraps from the actual cafeterias on campus, anywhere from like vegetables to meats, leftover fruits, breads even. There's other things that out here at Bradford they've been putting in, like cardboard, paper towels, paper sacks, other things, anything that's really decomposable. We've been trying and test. We've got actual sacks that go into the barrels that we're going to start using that are decomposable plastics that are environmentally safe. Just trying to reduce the carbon imprint that Mizzou has overall.
Well, temperature in composting is the most important thing, because it's got to reach a certain temperature. You want it to reach at least 131 degrees, and you want to hold this temperature from 131 up to about 160 at the most for 15 days. Because if you can do this, then all the bad organisms will get killed, but it also will help break down the carbon to a form that's very usable by the plant.
Basically, in all this compost, there's carbon matter, and that carbon's got to break down, and by pulling air through it, you're getting more surface area being allotted to the air, and it helps with the bacteria that are breaking down, with the pathogens that are needing to be killed off to make it safe and usable for vegetables or for any type of flowering plots or any type of flowers used in plots or whatnot. My part in the whole project has been doing the calculations on the actual pipes that will go into the bays here, and the pipes are pipes that run about 4/5 of the actual bay length. We're going to pressurize them and pull air through the pile and then into the pipe. It will draw all the moisture in the actual compost out of it and down into the pipe, and then pull it out the back end along with that air. And it should speed up the overall process of composting, so that instead of looking at 3 months max, we're hoping to get down to 2 months, 1 month, trying to make it a quick process. That way, with the amount of food coming in, we're never sitting here waiting to open up another bay because we have too much stuff. So we're trying to move it, make it efficient, and use the space we've got. As everyone knows, a lot of our excess material does go to landfills. You put out garbage every week and it disappears, and it's got to disappear somewhere. Well, what Mizzou is trying to do is trying to reduce their actual waste going to landfills. And by just removing the actual food particles and any type of paper product and putting it into this composting project, we've reduced weekly by at least 4,500 pounds of food and other products going to the landfill, which to me is really rewarding. They say that going green and being environmental is the way to go as we head towards the future. And by doing that, I feel like I'm starting up a process that will hopefully continue through the coming generations of Mizzou students.
Well, we developed this with the idea that students should be part of the whole picture. And as you saw, Brent is one of the engineering students, and him and Logan are the ones that are figuring up the correct way to compost. Because it's a science and an art. And we could have purchased the technology to do it. Why do we want to do that for? Let the students figure that out. And let them tweak it. And it's not going to be just a system that's going to be the same thing all the time. I want the students to try to make it better, try to use other products, other ratios of air. Let's fine tune this process and make it an ongoing system. And we only have one environment. And the most that we can do to protect our environment, but also to get new ideas about how to market, how to be entrepreneurs, how to value add a waste product is just tremendous. And we got to do a better job with that. And I think this is a great start with that.
Tim, that's exciting. Let's get down to the nitty gritty of it.
All right.
You're taking food waste and horse manure.
And bedding.
The straw that goes with that. And some other products, paper products that are anything decomposable can go into this.
That's correct. That's correct.
And then what's the process that this breaks down?
Well, that's the composting process, and it's an aerobic process. And
aerobic meaning it has to have air.
With air,
to make
yes.
it work.
And we are depending upon the soil, the microbes, the bacteria, and the fungi to do our work for us. And we often think of those as being bad, but actually most of them are good. And the heat that you saw, the steam rising out of that, is from that activity. And that will actually kill many of the bad microbes.
You showed the thermometer. That's a really critical issue, is to get that warm enough so that any bad microbes are destroyed.
That's correct.
But that also is part of the decomposition process.
Yes, because it's some bacteria that are breaking down the cellulose and the lignins and what have you.
And how hot does it get in one of those piles?
It can get well over 150 degrees, but we don't want to get that hot. We don't want to get much more than that. So one way of doing it is to aerate it, or to mix it, or to add some more carbon, some more horse bedding. So
there's a mixture here. I mean, you don't really know what kind of food waste that you're going to get. Your straw and horse manure is probably more reliable, but the food waste, does that make a difference? I noticed one of the shots had quite a lot of bread products versus there might be vegetables. How's that all break down? Well, generally, we've done some estimates, and it gets about 20 to 1. Yeah, it sometimes varies a little bit. But as you mentioned, the straw and the bedding is very consistent at 40 to 1. Every day is something different. We notice the kids eat pretty good sometimes. They eat better than I do. I saw shrimp in there one time. And yeah, it didn't seem like the college food that I remember. No, it's not. And you mentioned earlier how it wasn't the dorms or the cafeterias. Fresh local food is so important now. And that's a big movement, and that's a big important movement. It's important to the kids because a lot of them are coming from environments where they're used to that, used to eating fresh vegetables and so on. They are, and being more healthy. And my two daughters that are in college, they just shame me to death all the time. Okay, so your end product then is a composted. So most of us are familiar with it. You can go buy bags of composting material at the store. Is that the absolute best soil then to use for growing fruits and vegetables? Well, it's a way to add to our soil to help continue to feed those microbes and also to supply nutrients. Okay. And between the more microbes and nutrients, we should have a much better crop. This is a little bit tricky for us, but we're gonna try a little demonstration. We are. Two kinds of soil here. I did. Let's see how this goes. The first soil that I brought, this is what we've been tilling for 50 years. And another one is it's been not tilled. It's been no-tilled. It's had a permanent crop on it. So look at the difference in color already. And what the difference is, this has lost most of its organic matter, where this hasn't. And by applying our compost, we are essentially putting the organic matter back into the soil. And we hope to turn this into this. And so you got a little demonstration here to show the difference. Right. So we'll see how this holds together. This is the one that's been tilled a lot, whereas this one has not been. And what we're looking for is what's holding this together. And if you can see the one that's been tilled, it's already starting to break up, where the other one really hasn't. It's holding itself together. The organic matter is kind of creating a grip, which is better for soil. It's going to hold nutrients better. It's going to hold water better. It's going to allow water infiltration better when it has this nice structure to it. And it's not only the organic matter; it's the secretions that
bacteria and the fungi produce. That helps hold it together.
That's an important part of this. There's more microbial activity in that organic soil, right?
That's correct.
And go ahead.
Oh, I was going to say, in a teaspoon of soil, there are millions of bacteria, of good bacteria, and yards of fungi filament. And all that is what helps hold the soil together. And you can see this one is still together, and this one is starting to flake off.
So my son's working in Iowa, and he's kidding me about our lighter colored soil. He said
right
it's all black. And that's a higher organic matter naturally in some of those locations, where Missouri is going to run about 2%. Is that about right?
That's correct. This one is actually 1.9%, and this is about 3.7%.
And over how much time did it take of using this material to build up to that? Do you have any idea?
It would take 5 to 10 years to get it built up.
To build that back up.
But the thing is, it breaks down much faster than that.
So on a farm or in a garden, a person could gradually improve their soil organic matter and tilth and all that microbial activity over time.
Exactly. And even before your organic matter goes up, your soil microbial activity will just skyrocket.
So where is this soil being? Are you using it on Bradford Farm, or are you using it somewhere else?
Yes, we're going to be using the compost to fertilize. We'll use it as a soil amendment to fertilize, to feed the organisms, to grow the vegetables. Okay. That go back to campus dining.
And so you've got a complete cycle going.
We sure do.
Can you give us some idea of how much fruits and vegetables you're providing back to the campus?
Oh, we're in that 5,000 to 6,000 pounds during the summertime, and we've got some hoop houses. We've got 8 hoop houses that the students will be growing cold crops in, that lettuce and broccoli and cabbage. And
well, let's try another demonstration. Excuse me just a second. I'm going to drop down here, and here you've got plastic bags with the 3 products.
Right.
And this is what you start off with, more or less?
Sure is. That's our bedding material from the horse farm. As you see, it's straw, it's some sawdust, and some manure. Just a little bit of everything.
And so that's basically what you're starting on. And you're adding food waste. And that combination of the cellulose and the straw and the more concentrated carbon in the food waste is a pretty critical issue in the composting, isn't it?
It's the nitrogen in the food waste. That's really important also. Because all of our microorganisms have a ratio of carbon to nitrogen of about 25 to 1. So if we want them to break down this material, we've got to provide that right combination, about 25 or 30 to 1.
So that's the mix you're trying to get.
That's a magic mix.
One of these is a medium step, and then one is a final step.
Almost final step, yes. Let's see where we got. Let's see where we're at. Oh, this is getting really close to the end, and this is. Yes, this has been composting for about 2 weeks.
So you can see it starting to, after only 2 weeks, it's breaking down that much.
And it's got a little bit of smell to it.
I was going to say, I wish we had smell-o-vision for the folks back home, because this has got not an unpleasant smell, really, but it's pretty strong.
It is.
And then this is more of a final product here.
It sure is.
And so that's really breaking down to where it's almost soil.
That's right. That's correct. That's correct. You give us another few weeks, and it's going to be in really good shape.
Can somebody do this at home? I mean, you've got skid steers and concrete and so on and so forth. Can somebody do this at home if they want to improve their yard or garden?
It's very easy to compost. As a matter of fact, I tried this at home on a very simple scale a few years ago before we got into this. And it's as easy as I put 4 T-posts down and put some woven wire around it and just start putting in our food waste. Any plant debris that we had, or just anything organic. Leaves is
grass clippings.
And with the idea that I want to be somewhere, try to keep that ratio. And if you don't do anything with it, it'll eventually turn into compost. It'll eventually turn into something like this. But the more you turn it, the more you aerate it, like we talked about, the faster it'll go.
I see in some of our garden magazines, they actually are manufactured composting bins that you can turn it, kind of do the same thing you do, only a smaller scale.
That's correct, because all it's doing is aerating that pile some more.
And a homeowner could get rid of you mentioned paper towels and that sort of thing. You can add a lot of that cellulose product to your food waste and get rid of a lot of stuff that's currently going into a landfill.
Exactly, exactly. And there's materials out there that you can look up and get a general idea about what your paper towels will be, carbon to nitrogen ratios and others. Because it is important to try to keep that.
I assume the university's probably got some guidelines that are online.
Yes, they sure do.
I know you guys are doing lots of things that are green and this whole, well, we like to talk about sustainable agriculture, but you guys have got several projects, biodiesel and others.
Right. Well, we wanted to make this whole project totally carbon neutral, or even let's sequester some carbon, make it carbon negative. And again, talking to campus dining, and I thought, what do you do with all that vegetable oil? So, oh, we've got to pay somebody to take it off. And found out they go through 3,000 gallons per year. So we're always thinking about something to do. So we started making biodiesel out of our waste vegetable oil. And that runs the trucks then that pick up the food waste and do some of our composting. You saw a tractor running that we can run on biodiesel, and then also grow the vegetables and take those vegetables back to campus dining. So we make that whole circle without outside carbon sources.
So yeah, you're approaching carbon neutrality, or no, so even like the little skid steer loader and those things are able to run on diesel. Is that a difficult process, making the waste oil products into diesel?
It really isn't, but as anything, much like composting, there's science behind it, but there's an art to it too. And our first stab at it didn't do quite as well. We learned some items like you want to make sure you don't have water in your oil. That's a big problem. And you want to get not as much animal fats in it. But once we got through a few of those stages, boy, it runs. Within 2 days of starting, we can have a finished product.
You can have finished diesel fuel.
That's correct.
And I thought the other aspect of this that I think is fascinating is how much student help and student involvement are in this process from start to finish. You've got students growing vegetables and managing the compost and so on. Tell us a little bit about that.
Well, we wanted this to be educational, and as the video said, that we don't want to buy technology when we can have the students develop it, and that's a huge part of it. And also growing the vegetables. I'm accused sometimes of giving people just enough rope to hang themselves. Because with the students growing vegetables, we give them the guidelines, generally what we want, and then we turn it over to them. Let them learn by doing. And they make some mistakes. They've taught me a few things too.
I bet you found cases where they've done some outstanding things just because they're so innovative.
That's right. That's right. You've got these students thinking, and Brent was a perfect example of that. They changed that aeration system from what I thought it was going to be like.
Bradford Farm is where from campus. Most of us are familiar,
right.
Probably familiar with the football stadium more
that's
than anything,
right.
with the basketball arena, but there's other parts of the university.
Yes, that's right. We're about 6 miles east of campus off of WW and then Rangeline Road.
And I assume you have some field days and some visitation days where people can come out. You don't want people just coming out willy-nilly, but you do like to have people out.
Yes, we do.
Times.
We have all throughout the summer, we have field days. We have student groups come out. Just give me a phone call, and we can always arrange something.
So if you had a group of high school students or something, you can make special arrangements to come out and visit.
That's correct. We especially go after.
We're about to run out of time. Is there any other special projects that you're doing at the Bradford Farm you want to talk about?
Well, we do everything from growing freshwater shrimp, and we're going to start working on growing saltwater shrimp in just this next month or so.
Yeah.
So we're looking at innovative ways of doing that. We try to make Bradford Farm as energy efficient as possible, not use as much propane, and we burn recycled pellets for our heating source, and working on a lot of renewable energy. So
we talked a lot about green jobs and green technology. Do you think this is something that can be spread throughout the state? I mean, that's really the role of the university, is to develop technology that can be spread out to people's homes and farms.
We want to be that model that the rest of the institutions can use. And what we find out is they may start it and then innovate it, make it so much better than what we actually started with. And that's what we hope.
There's somebody out there with some young man or young lady with a brand new idea. That,
gosh, I hope so. I hope so.
Tim, thank you very much. And
thank you,
congratulations. Very innovative on your part, and a lot of people would say, no, we're just going to do it the way we've always done.
Oh, no.
So I appreciate what you've done. But I'm afraid that's all the time we have for tonight. I'd like to say thanks again to Tim Reinbott for being with us tonight, and thanks to everyone at the Bradford Research Farm, the South Farm, and MU Dining Services for letting us visit with them as well. Before we go, we'd also like to thank you, our viewers, for tuning in to Show Me Ag, and we hope you'll tune in next time for another look at a topic touching rural Missouri. For everyone here at CamWest and myself, good night. We're also very interested in what you have to say, so if you have any feedback you'd like to share with us, email us at showmeag@kmos.org, or you can find us on Facebook.